a cave is a hole in a rock. How does a hole end up in a rock? Something has to create it, a force of some sorts. Now, if, as many people today believe, that caves need tens or maybe hundreds of thousands or millions of years to form, because it's a slow dissolution of the rock by certain water laden with some chemical elements, right? Some acidity. Then of course, the Bible cannot be true, because the Bible says the world is young. So what do? Can we prove that basically caves can form quickly? Of course we can. My theory is basically just trying to compress time, right? So here you have a clear evidence. You have two different igneous rocks placed one after the other. And that's a fast process, because if this lasted for a very long time, this rock would not look this fresh first, and then you'll have a lot of other activities happening in there, chemical stuff and all that. So this happened in the recent past. Lava, magma actually in this case, moving through inside the earth, right? And there's the granite, and there are little pieces of basalt you see here. The granite digested, it was injected into the basalt, and it took little pieces of the basalt, and you can see them floating there, quote unquote, of course, in the granite. But this is how volcanic activity actually builds the entire mountains, because all the cascades here, all the coast range as we call them, are made of granite. There's a huge amount of granite in there, and that's been in place very quickly. It didn't take millions of years to be in place like that. So what I'm trying to show you here is, for example, stalactites, stalagmites, but it's essentially what we call speleothems, little stalactites that have formed very quickly. How long it needs a stalactite, which hangs from the ceiling, or a stalagmite that grows from the bottom, to form? Is there need for millions of years? No. If you go to a show cave, you will have a guide telling you that stalagmite has been dated to 10,000 or 15,000 or 60,000 years. How? By using radiometric dating. Fine. But then you go and look, this is, there's a stalagmite growing on a handrail, or maybe on the concrete sidewalk that you just laid in a cave for the show cave. Well, that couldn't have grown for hundreds of thousands of years. And they tell you, oh, that's a case of exceptionally fast growth. So here's an interesting thing. You see it happening fast, but you prefer to choose that the other ones didn't form fast. Why? Because you have to defend a worldview, which means millions of years and evolution happening. This is how cement, or concrete, heals itself. So you got the water coming through the wall, dissolves a part of the limestone and redeposits it as calcite. So you see this is a crack?
So wait, this is calcite?
This is calcite, the white stuff here. You just have a crack in the concrete, enough for water to come, dissolve a part of it and redeposit as a pure calcite.
So wait, how long do you think this calcite has been there for?
60 years, well, this less than that. This must be 20 years max. I don't think it's more than that. So water infiltrates from the surface, dissolves a part of the calcite in the rock, and redeposits it inside the cave. Why? Because it comes through narrow cracks, the pressure is very high. The moment it reaches the cave, it loses pressure, it loses carbon dioxide, and precipitates as calcite. That's the joining of two sections of the tunnel. So the water infiltrates, and this is not limestone. That's my point. The rock itself is granite, there's no calcite in it.
Right.
All the calcite comes from the concrete. And from that little calcite, you get this much growing already. Now try imagine the mountain above is hundreds of meters of limestone. So then the water infiltrates and dissolves the limestone. This would grow a meter in 100 years. And if you can have stalactites forming in less than 100 years from a thin layer of cement, you can imagine how much faster and bigger stalactites and stalagmites can grow in a cave carved in limestone. Let's look at the way of looking, basically, at the fossil record. The fossil record is a succession of fossils as they are preserved in rocks, right? If you look at it as a geologist, understanding what that represents, dead creatures buried and by very strange unknown processes turn into stone, because I need to make this point very clear, nobody can produce a fossil today. In the sense that a fossil is not just burying a dead creature into concrete, for example. No, you have to replace the organic matter in it with mineral matter, and nobody can do that. But anyway, you look at these fossils, you can only interpret them in two ways. Either they are the result of creatures having lived over a very large expanse of time, dying and some of them being preserved as fossils, and that's the evolutionary way of looking at things, or they're all the result of one global hydraulic or water catastrophe that has buried things, creatures, according to their habitat. You look, for example, at the ocean today, from the bottom to the surface, you have a very clear zonation, a very clear distribution of the kinds of creatures. At the very bottom, the bottom dwellers are usually primitive, quote unquote, simple creatures. The higher you go up towards the surface, the more complex the creatures. Right on the surface, you have the mammals. Now, let's just assume that the whole thing has been dumped with a tremendous amount of sediments and buried in there. Which are the ones that have the highest chance of being buried and fossilized? The bottom dwellers, the simple creatures, the primitive creatures. Which have the least chances of surviving as fossils? Is the mammals on the surface. For example, nobody's ever found a human skeleton at the shipwreck site which is older than 50 years. Why? Because the ocean itself dissolves the bones. So, the chances of mammals surviving as fossilized items in the rocks are very slim. And guess what? You look at the fossil record today. We have inventoried maybe more than 500 million individual fossils known worldwide. 99% of those are, guess what? Marine invertebrates. Creatures without a backbone that live in the bottom of the ocean. 99% of those. Dinosaurs do not represent more than, say, 0.1% of all the fossil record. Humans, virtually nothing. I mean, we know more about dinosaur history from the bones preserved in rocks than we know from humans. And allegedly humans are the most recent of them, or we should have much more evidence. We don't. If there was a global flood, it's not difficult at all to explain it, that the fossil and the rock record as the result of that. But that means one thing, that there was a global flood.